Today's video is going to be incredibly interesting. I'm going to share a specific prompt with you that enables the WAN 2.2 model to generate videos with extreme dynamic motion. The videos you are seeing right now were all generated using this exact prompt structure. After generating these videos, I realized that prompts are generally universal. So I had a sudden idea, why not try this out in LTX video as well? To my surprise, the results were also fantastic. The motion in every video was incredibly strong. This led me to another thought. I wanted to compare the WAN 2.2 model against the LTX video model to see which one performs better, specifically when creating these high-intensity, dynamic videos. As you can see, we have two sets of videos. One set is generated by LTX video and the other by WAN 2.2. They use the exact same prompts and reference images. So what conclusion did I reach? Don't rush, we'll go through it step by step. First, I want to clarify that I didn't invent this prompt. I saw a post on Reddit where the user divided a 5-second video into 5 beats. Each beat features a key action. Now you might ask, is one beat always 1 second? Not necessarily, it depends on how long the action takes to unfold. For example, look at the prompt we are using. It describes about 4 key actions. The starting image is a man sitting on a chair. So, from 0 to 1.5 seconds, the action is man points at the viewer. From 1.5 to 2 seconds, the action is stands up and squints at the viewer. Then, from 3 to 4 seconds, man starts running towards the viewer, and from 4 to 5 seconds, he dives onto the ground. You'll notice the first action takes 1.5 seconds, while the second takes 0.5 seconds. It really depends on the time needed to display the specific movement, so you can adjust this flexibly. Below that, there is a crucial description regarding the lens and cinematography, which is labeled as camera work. Finally, there are some quality descriptors like 4K, cinematic lighting, and clear texture, which are standard for improving video quality. The post also explicitly mentioned that this writing style works very well for showcasing motion, even when using a 4-step acceleration LoRa. Is that really the case? Let's run a WAN 2.2 workflow to find out. As always, I've set up this workflow on Running Hub, and you can access the platform via the link in the ComfyUI space. Running Hub is a fantastic online workbench because they update immediately whenever new models or extensions appear. You can register using the invitation link in my video description to get 1,000 free credits. Plus, logging in daily gives you an extra 100 credits. So you can test these workflows yourself. What you're seeing now is a standard WAN 2.2 workflow. We've used this many times in previous videos, so I won't go into the details of the nodes. Let's look at the reference image. It's a female secret agent sitting on a chair. The overall lighting uses cold tones, making it look very sharp. My resolution here is set to 960 x 544, though you can use 832 x 480, it doesn't make a huge difference. The key is the prompt. It's essentially the same text I showed you earlier, but I changed the protagonist from a man to a woman. No other changes were made. Let's look at the final result. We requested 4 actions. In reality, we see about 3. The missing action is the one where she points at the viewer. However, the major movements standing up, lunging toward the viewer, and falling to the ground are all there. The overall quality is excellent. Now, let's look at LTX video's performance. The workflow you see here is the GGUF version I released previously, which is designed to run on low VRAM. The GGUF version means 2 things here. We are using the GGUF main model, and for the dual encoders, the text encoder is also GGUF. There is one critical thing to watch out for when using this workflow. Kijai's VAE, you must select the old version. He recently uploaded a new version, but when I use the new one, I get glitchy, colorful static during sampling. So stick to the old one. The prompt is identical to the previous one. Looking closely at the result, it also missed the pointing action. However, the remaining actions are present, including running and falling. Visually, WAN 2.2 looks a bit better, but remember, I'm using the GGUF model for LTX here, and the original WAN workflow includes an upscaling process, whereas this is a raw output. In terms of motion representation, based on this comparison, they are about the same. Let's move on to the next example tested on WAN 2.2. It shows a girl in a wedding dress holding high heels running through a church. I chose this image specifically to test very intense motion. I won't go through the prompt in detail, but let's compare the motion first. 1.2, the dynamic feel is fantastic. She runs, looks back, falls, drops the heels, and keeps running. It creates a very tense atmosphere. Now LTX video. We can see some issues here. Did you notice the shoes don't have soles? That's a rendering flaw. However, regarding the overall motion performance, I feel LTX video is actually slightly better than WAN 2.2 here. The sense of tension and atmosphere feels more intense. For the third scene, the reference image implies extreme motion, an elf shooting an arrow, the state of the bird flying, the dust rising from the ground, and the falling leaves all suggest a snapshot taken during high-speed movement. What happens with our prompt? 1.2, the elf shoots and the camera rotates. However, the way the dust rises and settles feels unnatural, not quite right physically. LTX video, I personally feel LTX handles the overall motion better here. The effect of the flying dust and the falling leaves looks more natural than WAN 2.2. The fourth scene is a Western female warrior holding a sword, wearing silver plate armor and a coarse cape. The prompt focuses on her swinging the sword. WAN 2.2. The performance is very beautiful. Both the action and the visuals feel very smooth. LTX video, it also performs without issues. The generation quality is high, and the overall feel is comparable to WAN 2.2. The final test scene is unique because it features two people. The reference is a dynamic snapshot of two boxers in the middle of a fight. There are many details: sweat, muscle texture, and the intensity in their eyes. WAN 2.2. The result is decent, but nothing extraordinary. Even though we described many actions, it mostly just showed the punching process. LTX video, the motion here is much more intense. However, there is a fatal problem towards the end. The two boxers merge into one person. That's a major glitch. Also, we noticed that with snapshot style reference images, LTX tends to start with slow motion at the beginning and only speeds up later. So here are our conclusions from these 5 comparisons. First, the prompt writing style breaking down time beats is absolutely effective. In terms of overall generation quality, visually, WAN 2.2 looks better, but that's largely because we are comparing it against the GGUF version of LTX. However, regarding motion detail and intensity, LTX video often creates more intricate and fierce movements. For instance, the boxing punch was standard on WAN 2.2 but very intense on LTX. If you want a video with strong dynamic motion, this prompt style is the way to go. To make it easier for you to write these prompts, I've created a prompt generator. This is a prompt engineering script. You simply need to paste it into any large language model LM. Let me demonstrate. Open Google AI Studio, create a new chat, and select the Gemini 1.5 Pro model. In the System Instructions field, paste the prompt engineering text I provided. Then give it a subject. You can type a topic or upload an image. For example, I'll upload the image of the bride running in the hallway. It will generate 2 versions of the prompt for you, English and Chinese. You just need to copy the prompt into your workflow and run it. One quick reminder, if you are running this prompt in the LTX video model, I strongly recommend changing the parentheses to square brackets. LTX sometimes interprets parentheses as an instruction to generate text on the screen. It doesn't happen often, but it can happen. To avoid this annoyance, swap them for square brackets. In WAN 2.2, this is not an issue. That's all for today. What are you waiting for? Go give it a try yourself. Follow me to become someone who truly understands AI.